Hello, welcome to today's Thin Cloud Friday webinar hosted by the Cloud Security Alliance. This exciting initiative aims to raise awareness about the distinct challenges that the financial industry faces in cloud and cybersecurity. Taking place on one Friday each month, the Thin Cloud Friday webinars will provide valuable insights into best practices for financial institutions, covering topics such as secure cloud service procurement, risk management, and achieving compliance objectives. Don't miss out on this opportunity to enhance your knowledge and strengthen your organization's security posture. Today's webinar is titled ON2IT Zero Trust Implementation for Financial Institutions. We are joined by ON2IT Senior Vice President of Cybersecurity Strategy, John Kindervag, and Cloud Security Alliance's Senior Research Analyst, Eric Johnson. Before we begin, I'd like to make a few quick announcements. First, be aware that the slides from this webinar are not provided. However, a recording of today's session will be available shortly after its conclusion. Also, before you leave the webinar, please take a moment to fill out a brief survey located at the bottom of your screen. Your feedback is valuable to us and will help us improve future webinars. Thank you again for joining us. Now I'll pass it off to John to get started.
Hi, I'm Eric Johnson. I'm Senior Research Analyst with the Cloud Security Alliance, focusing on zero trust and also the financial sector, working closely with Troy Leach. I've about 30 years experience in the financial sector with both the Federal Reserve and prior to that with the World Bank. And I've been working closely with our main guest today, John Kindervag, who's been working with the Cloud Security Alliance for about the past year now, very closely on the subject of zero trust. A number of key respects. He's the co-chair of our Zero Trust Executive Steering Group. He's been actively engaged in our Zero Trust Research Leadership Team. He's made a number of contributions to our Zero Trust Advancement Center Resource Hub. He's also provided a number of informational presentations for our working group on some key topics. And it was out of that we recognized that some of the material he had prepared was sort of directly relevant to financial institutions. And so we had the idea that we'd have this FinCloud 5 focus session targeting financial sector specifically. So welcome, John. Thank you. And John is the Senior Vice President at ON2IT.
Hey, thanks, Eric. It's good to be here and talking to you all. And as we move forward, we're actually making a difference in the world. So everybody who's watching, remember, whenever you make security just a little bit better, you make a difference.
Indeed.
So today, we're going to be talking about zero trust in the context of financial services. And I'm just going to go through a little bit of background in terms of zero trust and how to think about it here to start with, right? So that we can have, I don't know, a starting point, right? So a lot of people are confused about zero trust. I'm working very closely with the Cloud Security Alliance to solve some of that stuff. And as background, I'm the person who created this when I was at Forrester. So I can arguably say that I have more experience doing this than anybody else. And what I want to do is take those lessons learned and give it to the community, right? Because you shouldn't have to make the same mistakes I made over the years. And so we're going to be talking about that today within the context of financial services. And so first of all, let's define zero trust. And it's a very simple thing, and a lot of people make it overly complicated, but I'm going to give you my official definition as the creator of it. So zero trust is a strategy, right? It's a strategy, a big idea designed to do two things. One is to stop data breaches. So we have this idea of data fueling modern economies. I'm from Texas. We say data is the new oil. But why is it the new oil? It's the new oil because, there's a base value from oil. It's called West Texas crude. But the more you refine it into gasoline, diesel fuel, aviation fuel, jet fuel, plastics, carbon fiber, nanotubes, the more valuable it gets. Refined oil is more valuable than crude oil. And the same is true of refined data. It's more valuable than raw data. And so we want to stop data breaches. Now, what's a breach? This is something that confuses a lot of us in cybersecurity, because we think of a breach as somebody got into our system. They're poking around. Oh, no, the castle walls have been breached. That's actually the definition of an intrusion. Someone is intruded upon our systems. The term breach has been redefined for us by legal and regulatory entities like PCI, CCPA, GDPR, and they all mean that a breach occurs when data that is sensitive or regulated has been exfiltrated from our networks or systems. It's about what's going outbound, not about what's coming in. And we spend too much time worrying about what's coming in and not hardly any time at all worried about what's going out. And this is the key thing. You got to know what's leaving your system, not just what's coming into your system. So we want to stop data breaches because data breaches are the only thing that IT can do to get a CEO fired. The CEO of Target was fired over a credit card data breach. The CEO of Equifax was fired because credit reports were stolen, right? So we need to understand that particular concept. And then the second thing we can do is we can make other cyber attacks unsuccessful, right? There's two types of cyber attacks, successful ones and unsuccessful ones. I can never stop a cyber attack from starting because I'd have to be the attacker, but I can certainly make it unsuccessful. And that's what Zero Trust does. It makes a lot of cyber attacks, in fact, most of them unsuccessful. And the way it does it is it eliminates trust from digital systems. In Zero Trust, trust is always a bad thing, right? People confuse human beings and digital systems, and we're not trying to do that. We're trying to eliminate the concept of trust from digital systems. And so if we do that, we can achieve these two grand strategic goals of stopping data breaches and making other cyber attacks unsuccessful. Now, in order to build a zero trust environment, there's a 5-step methodology for deploying it. And you must understand that as we move forward in our journey. And this comes out of having designed and been involved in the implementation of the first dozen or 2 dozen or 3 dozen, who knows, zero trust environments. I found there were 5 things that were in common with every single one of them. And if I followed this 5-step methodology, it was always successful. If I didn't, it was unsuccessful. And so this is your 5-step process for being successful. This guides your journey. So the first thing we want to do is define the protect surface. And you can see other presentations and things that I've talked about what is a protect surface. But basically, we're shrinking the attack surface orders of magnitude to something very small and easily known called a protect surface. So a protect surface just reduces what we have to worry about, right? General Greg Toohill over at CERT likes to quote Frederick the Great, who once said that he who protects everything protects nothing. So we have to figure out what's important to protect. And Eric, you mentioned Troy Leach, who's a longtime friend of mine. I am a recovering QSA. I've done a lot of PCI work. I worked with Troy and his team back when the PCI Security Standards Council was first starting. I was one of the first generations of QSAs. And what we learned to do was protect a binary data string called a PAN, or a personal account number. So all PCI is concerned about is one binary data string called a PAN. And we talk about that data as PCI, and we're going to talk about PCI data today. We're going to use that as our example. But what we want to do, that became for me the concept ultimately of the protect surface. And so what we do is we define what we need to protect. And that's known as a DAS element. And you can read the DAS element in various guidances. The NSTAC is the most important, and I'm sure we'll share that to you. I sat on the President's National Security Telecommunications Advisory Committee subcommittee on zero trust and trusted identity access, which is certainly a mouthful, isn't it? But that report authoritatively defines what zero trust is. And we talk about a DAS element. A DAS element is data that is sensitive. It's applications that use sensitive data. It's assets that use sensitive data or are sensitive. There's all kinds of assets that have various levels of sensitivity. And then we have services. Things like DNS, DHCP, Active Directory, very sensitive. If they go down, your whole environment goes down. So we take a single DAS element and we put it into a single protect surface, and we build it out one protect surface at a time. In this way, zero trust becomes 3 things, and I want you to remember these three ideas. It becomes incremental. We're doing it one at a time. It becomes iterative. We're doing it one after another, and it becomes non-disruptive. The most you can screw up is one protect surface. And then the second thing that we're going to do is we are going to map the transaction flows, understand how the system works together as a system. Now, this comes out of an error that we made early on in deploying one of the early zero trust environments around a point of sale system, which of course included that PCI data, because somebody took out a server that they said was old, right? We'll talk about old and legacy stuff, I think, probably later. But hey, this is old, we'll take it out. Well, it was integral to the system, and we brought down 3,000 restaurants because of that, because we didn't understand how the system worked as a system. And so that's why I added step 2. Some people say that just seems like a lot of extra work. No, it protects you. And so you need to do this so that you understand how the system, because where you work and the system you're working on, there's probably no one there who was around when it was deployed. That institutional knowledge is gone. And so you need to do some research to discover how that works. And then the third thing we're going to do is architect the environment. Unlike traditional environments where we started with a reference architecture, zero trust is based or built upon a protect surface. So every zero trust environment is architected to meet the needs of the specific protect surface. People get really into the technology and the products. And so they'll call me, hey, John, I bought widget X or gadget Y. Where do I put it? I don't know. What are you trying to protect? Well, I haven't thought about that yet. Well, then you will fail. You must start with what you are protecting. That's how you protect anything, right? So you start with what you're protecting. If you don't know the answer to that, go back and figure out that answer. And then the fourth thing we're going to do is define the policy. Ultimately, zero trust is instantiated as a layer 7 policy, right? So I'm going to need layer 7 controls to enforce that. And then finally, we're going to monitor and maintain. That's where we take all the telemetry and we re-inject it back into the system to create a feedback loop. And this creates an anti-fragile system. And I always have to take a moment here to write as I am spelling at the same time, because that's more difficult, you would think, when you're doing a live webinar. But anti-fragile, this comes from a book by a man named Taleb. He wrote The Black Swan, so you might be familiar with that book, but you should read Anti-Fragile because he gave me the vocabulary to talk about what I was trying to do with zero trust, create a system that gets stronger and stronger under load, under attack. And that's what happens in zero trust. The more you're attacked, the more you have data, telemetry, the more that you can make each part of the system stronger and stronger and stronger. That's known as anti-fragility. So zero trust, typically we start with segmentation. People say, well, I need to segment my network. And I'll say, why are you segmenting my network? And they'll say, well, we had an audit finding that told us to do it. Well, that's the compelling event that's going to force you to finally get around to it, because you should have been segmenting your network a long time ago. But the only reason to segment your network is to protect something. And this is why we start with the protect surface. So we have a protect surface here known as a cardholder data environment. This is the term we use in PCI, right? So our DAS element is PCI. That is the slang term for the card, the PAN, the personal account number. But things involved, we could just call that PCI data. That just has become a slang over the course of the last 20 years or so. So we're talking about PCI data. That's what we need to protect. That's our DAS element. Okay. This tells us why we are segmenting. Most people segment without even knowing why they're doing it. You segment it to protect something. Now, once you do that, you must install a segmentation gateway to create a micro perimeter that enforces the segmentation up at layer 7. Why do I say layer 7 is so important? A lot of people are saying layer 3 is good enough. No, layer 3 is what we had in 1992 and 1993 before we had stateful packet filtering firewalls. We had layer 3 ACLs, and that's what a lot of people are defaulting to now. And it scares a lot of us who are older, who were around back then, because we know how easy it is to toast layer 3 controls. And so all attackers know how to bypass layer 3 port and protocol controls, you must be up at layer 7. So you must have a segmentation gateway. And this is the term that I originally used at Forrester to define a gateway that segments networks layers 2 through 7 based upon applications, data, users, various criteria that we're going to control the segmentation. And these can be virtual segmentation gateways, we call them VSGs, or physical segmentation gateways. Sometimes you'll hear people talk about them as policy enforcement points, but that's not a very specific term. And it also confuses with the management console, which is the policy decision point, I think. And so I always get confused on that, and so does everybody else, because there's one letter changed in some of these things, and they just aren't specific enough. The purpose of the control is to do the segmentation. So that's why it's always been called the segmentation gateway. And so once we do this for the cardholder data environment, we can just build it out one protect surface at a time. So in this way, it becomes incremental. Remember, one at a time, iterative, one after another, and non-disruptive. The most that we can screw up is one protect surface, right? So that's pretty cool. Now we end up talking about how we write policy, and this is known as the Kipling method. Who, what, when, where, why, and how was depending on who you talk to, but it was really reintroduced to us in a poem in 1902 by the writer Rudyard Kipling, who wrote the Jungle Book. Right. So you've all seen the Jungle Book, I hope. Well, one of the great movies we had as kids, super fun, Baloo and Look for the Bare Necessities and all that kind of stuff. So I'm fixing to go to, I'm from Texas, so we fix to do things. I'm fixing to go to Disney World soon with my family. So, thinking about all those old Disney movies that I saw as a kid and the ones that I showed my kids. And so this is an homage to Rudyard Kipling. He gave us the idea of who, what, when, where, why, and how. And the thing about that model is that it works in every culture, every language around the world. And because I'm a global resource, I travel around the world. I have to have things that resonate, not just with US audiences, but global audiences. So we can define these statements. We call them a who statement, for example. Who should have access via what application? When should that happen? Where is that resource located? Why are we doing it? And then how should we look at the packet in order to decide whether that user should have access to it? So we can define these statements. So if we have an application that we're going to call the PCI application, right? So, or the payments application maybe. So payments is our app ID. Right. So that is above port and protocol. It's exactly that application. So we can say that what statement, right, is the payments app right down here. And then who should have access to it? We call that user ID typically. So who should have access to it? So we'll say that's going to be the OU of payments, who are the admins for the payment system. You don't want everybody to have access to all of this stuff, because then they'll do bad things. And there's a lot of great hacks that show you how insiders do that. So now we can then add an authentication type, some sort of multi-factor authentication, and that user ID is payment admin. So we're starting to build these things out, right? So we now have a when statement, working hours, where is it located, right? That's the payment protect surface. We can define that. Why are we doing it? Because PCI DSS requires us to do it. And then how are we looking at that packet, right? So we call that a content ID typically, is the term. These are Palo Alto terms, but Palo Alto Networks terms, but they've kind of been adopted by the rest of the world. So we're going to, for example, this doesn't need URL filtering. Right? It will have IPS or threat protection. We'll decrypt it to make sure we can look inside the packet. We'll take any attachment and we'll run it through a sandbox, and we'll probably add some DLP. And so we'll make a statement that if all of these things are true, then we will allow it. Zero trust is a set of granular allow rules. We almost never have a deny rule that we need to put in zero trust because we start with a default deny. And remember, all policy is binary. You can have multiple criteria like you see here, but you're going to end up with either an allow rule or it's just nothing's going to happen because there's a default deny. And what I want you to understand here is all bad things happen inside of an allow rule. If you have a bad thing that happens in your organization, you had a rule that allowed it to happen somewhere. You were co-participating, maybe unwittingly, in the attack. And so you need to be looking at those allow rules. I see way too many people who, oh no, we denied something, let's investigate that. No, just give yourself a high five and keep looking at those allow rules. If you denied it, you denied it. It doesn't matter. I had a client recently. I want to know why we denied it, who was attacking me so that I can go out and prosecute them. That will never happen. That is, you're confusing physical crime with digital crime. I just was on a panel with the FBI and the Secret Service last week, and the threshold of evidence and size for the Department of Justice to prosecute somebody is so huge that it almost never happens, right? So don't worry about that kind of stuff. Get your head into the digital world and out of the physical world. And if you do that, then you'll start having success and you'll block the bad stuff. You'll allow the good stuff. You'll know whether the good is about to turn bad, and you'll be able to stop a cyber attack from being successful. And as a result, eliminate data breaches from your organization. And then you need to be able to score how you're doing this. This is the maturity model. And we'll also give you a link to a blog post that I wrote for Cloud Security Alliance about how this maturity model, the original zero trust maturity model that I created at Forrester, works with the CSA 2.0 maturity model, which has all those pillars, which is designed to help you understand what technologies you will put inside of a protect surface. So our protect surface that we're talking about today is the cardholder data environment. We can call it payments, because you'll see me give a demonstration here in a moment where it's called payments. And the DAS element is PCI data, right? And so now we can we've defined the protect surface pretty well, because PCI is the easiest data stream to find. There's a thing called the LUN formula, LUHN, I think it's spelled, or mod 10. So we know mathematically what is a live credit card or just a number that resembles a credit card string. But maybe you don't know how it works very well. And you've got some basic security controls, but not very much. Some basic policy. Maybe you're doing a little bit of monitoring, maintaining, because you're doing some base logging to meet requirement 10 of the PCI DSS. But you want to get to a higher level. And that's what you use this for, is to help you define projects to get to a different level, right? So the top score you can have, the most maturity, is 25, 5 times 5. So this is a standard 5-step CMM model that you would see in most CMMs, from Carnegie Mellon. So at this point, I'm going to switch over to the portal from ON2IT to give you a demonstration how we do this. Eric, do you have any questions while I'm making the switch here, buddy?
No. Maybe as we go through the demo, I know you do have some good examples in there of different types of assets that financial institutions have, and as we go through some of that, maybe touch on some of the unique aspects. I know in a number of organizations I've worked in, there's a fair amount of sort of legacy or older technology, everything from mainframes and older versions of software and things like ATM machines, and also some OT type elements in there as well.
Right. Okay. Great. So I'm going to try to hide this thing here. Okay, here we go. So this is I work for a company called ON2IT. It's headquartered in the Netherlands, but I work out of Dallas here. And so this is our OXO platform. So this is how our customers look at the world. So you can see here we have a visual representation of the protect surfaces. So what you're seeing is real data that's been anonymized from one of the world's largest banks. And they allow us to do that because they're a very happy customer. And so we anonymize this data, and then we show here's the location of all the protect surfaces. You can see there's a list of them. You note over here, there's 28 protect surfaces is all for this global bank. So there are protect surfaces on 6 of the 7 continents that we manage here. We don't manage one in Antarctica, but there is a zero trust environment in Antarctica. And so if you ever see me in person and you want to grab a beer, I'll tell you the story of that one. I don't want to tell it on a webinar. And so what we're doing is we have the ability to create cases, look at open investigations. We're monitoring for exfiltrations and intrusions, and then we have advisories. But what I want to delve into is what this looks like in real life when you're actually deploying this. So this is our Zero Trust Fitness portal. This is how a customer looks at the various protect surfaces. So you can see the 5-step model that I just showed you is built into the portal here. And so we can see here's all the protect surfaces, the transaction flows, the controls, the policy, and monitoring and maintaining. And what we're looking at it is from a all protect surfaces point of view here. As it finishes loading, we see that it's all protect surfaces. And so what we're seeing is the aggregate zero trust score for this entire company, which is 18.4. And we can see that step 1, they averaged 3.8, step 2, 3.6, step 3, controls 2.7, step 4, policy 4.3, and step 5, monitor and maintain 4.1. And we can see the distribution of how many different protect surfaces. 17 are optimized, and 3 are at level 1, and we can see the gap and all this kind of stuff. So this is important to understand. But let's go in and look at the payments protect surface. So we have a payments protect surface right here. You can see it. I'm highlighting it. So it has a relevance score. That's the R. So I'd always encourage you to give everything that you do a relevance score. How important is it, right? And that's going to depend on your organization and not any third party. They can't tell you the relevance score. So an example in a hospital, here's one that was very interesting to me. I talked to the CISO and asked, what's the most relevant? What's the most important resource or asset, or what would be the most important thing to go into protect surface? And he said, our electronic medical records, because if we have a data breach, we get in trouble with HIPAA. Well, that was an interesting thing, and that's what I thought, right? And then I talked to the CTO over the entire hospital chain, and I said, what's most important? You know, the CISO said it was the EMR, and he said, well, you know, that's important, but that's kind of number 2. He said, our most important system is the computer system that runs the elevators. Because if the elevators don't run, patients don't move. If patients don't move, they die. So I'd much rather have a data breach than dead patients. And I thought that's a very interesting perspective. And this is why you have to talk to people outside of IT to understand what you actually need to protect. That's a great example of why you need to have a Zero Trust Center for Excellence that includes business leaders, not just IT people. So if I look at this payments system, this is for a bank, and of course, that's a relevance of 100. We can see its scores, and we'll show it to you in more detail later. But we've tagged that with the types of data that it has. It has PHI and PCI data. And here are the various compliance mandates that it falls under. So it falls under PCI DSS, right? Where Troy Leach used to work. This is really the most interesting of all the compliance mandates. Just a shout out to Troy and what they did. First of all, PCI is the same for everybody, whether you take 1 credit card or 100 million credit cards a year, it doesn't matter. So that's cool. It's the same for every place you live or work or process them, right? So it doesn't matter which country you're in. And what it did, it was so brilliant, and people underestimate this. I hear people griping about PCI all the time, and I'm like, well, when I started, both Visa and MasterCard had 2 different compliance mandates. So you had to have 2 separate assessments done. And they came together, the 5 card brands, to create the PCI Security Standards Council, which was brilliant, but they kept various governments out of it. What if you had to do a different assessment for all 50 states and every country that you were involved in? Do you realize how much time and cost that would be to take credit cards? It would ruin the credit card business. So just a shout out to Troy and the whole team over at the PCI DSS, because they performed a miracle. Now over here we see this is who runs it, the operating system. It's a Linux operating or Unix operating system, and the OU where it is in the directory system, and then the locations, right? So these are the locations: the data center, east and west. This is pretty important here. Once we know the operating system, this is running on Unix, probably on a mainframe. All the traffic that's a type of traffic, whether it's for or an attack traffic, it's got a Linux exploit, it's got a Microsoft exploit, it's Microsoft traffic, it's Linux traffic, it's whatever traffic. If it's not for a Unix system, automatically that can be dropped. That will never be useful in that system. The other thing, and this is a thing that to bring up right now, it's a Unix system, so it's probably running off of a mainframe, probably an AS400, right? Though people buy them all the time, and I hear people say, "Oh, it's a mainframe. That's a legacy technology." No, it's not. If it makes money for you, it is not a legacy technology. It is the reason IT exists, to drive revenue and drive profitability. That is our job in IT, right? And then from a security standpoint, we need to stop data breaches and keep everything up and running. So if it's making money for you, it's not legacy. And I remember I've talked to multiple banks, and all the DevOps people want to take the payment system and split it up and use microservices architecture to put it in a cloud because that's cool and sexy. And so then when the business says, "Hey, how much will that cost?" "Oh, that'll only cost $1 billion. That's not much for us." Great, but how will we make that back? How will we profit off of that? "Oh, well, that's not our job." Well, it kind of is your job to think about those kinds of things, to think about the business implications. So if we go into that payment system and look at it in more depth, right, we can start to understand some things about it. So we've defined the protect surface. We know it's a payment system. We know what kind of data it has. We know its relevance. And we know that the internet or something is slow right now, is what we know, which is always the problem of doing live demos, right, Eric? So let's try to go back up here and go back into here and see if it will respond to me better. Okay, now we've drilled down into the payments protect surface over here. And again, we see that the zero trust score for payments is 18. The defining the protect surface is a 2. So that should be higher because we should know more about that data. But for whatever reason, we've got it at 2. We understand a little bit about the transaction flows, but we've got some good controls and architecture. We've got some decent policy here, and we are monitoring and maintaining it well. And so we see all this metadata attached to it, and we can see here the protect surface maturity model. We can see where we are. So again, you want to look at both the overall everything, from like the pillars standpoint, but you must understand the maturity of each individual protect surface. And down here, we see the location of the data centers where they're located and their IP addresses. Of course, these are internal. Somebody's going to say, "Well, those are RFC 1918 addresses." Again, we've anonymized this stuff, right? So you're not seeing the real addresses. And so then we can go into the transaction flows and look at that. That's not particularly interesting because I want to spend some time looking at the controls and architecture. This is how you end up looking at and defining the maturity model from the pillars. So if I look at what we're seeing here, this is mapped to the MITRE attack frameworks. Primarily, we've got it mapped to multiple things, and soon you'll be able to write the report on how this maps to the CISA 2.0. But traffic flows, for example, is network, right? And so we're looking at, does this have proper segmentation? Does it have restricted outbound access and inbound access? Does it have application-based controls? Does it have content inspection, URL inspection, and behavioral analytics? Those are the things that we have determined from our experience are most important. So you see endpoint, which is a separate pillar. orchestration and automation is a separate pillar. IAM is part of the user pillar. So you can see that these things are all in here. We've got a little bit different terminology for them. And what's cool about this is, as you look at everything across multiple protect surfaces, if I select all the protect surfaces, we'll find one that we'll be able to look in and see what's going on technically with each individual protect surface, and we can see where we need to focus our efforts to make everything, or to make a particular protect surface more mature, more able to withstand attacks, more able to stop data breaches. And so this is now an all protect surfaces point of view, and we're going to take a minute to refresh here. But we can see, again, there's 28 protect surfaces, 81% of the control, we have controls for 81% of the requirements that are active with evidence, meaning we can see it on the wire. And then there's some that are not assigned or not applicable. Some are active without evidence, meaning you've told us that you're doing it, but we can't see it on the wire, right? So that's a pretty big distinction. So now we're looking at multiple different protect surfaces. So we can see the ATMs, and we can see traffic flows, endpoints, encryption, orchestration, threat management, all the various things you would need, DDoS. So we can look at a particular thing and see, for example, this ATM, we don't have exploit prevention on the endpoint security. That's a pretty big gap, and we want to have that. We don't have behavioral analytics on the traffic flows. So that's a gap. And so we need to kind of think about this overall. And you can see as we scroll down here, when something's red, the trade portal, we need some application-based controls. These are, let's move beyond port and protocol in our network controls to an app ID-based control. We need content inspection. We need some URL filtering. We need some behavioral analytics. So this gives us a view of where we need to focus our controls so that we can make it more mature. And so we can see one here, SSL outbound decryption. This is something that people don't think about. We don't see, everybody wants to encrypt everything, and they don't think about how important it is to decrypt it for two reasons. One, I need to see, is there attack traffic coming in? But two, I need to see whether there is data being exfiltrated out, right? Because attackers, what do? They take the data that they've staged, and then they shoot it out via HTTPS because they know 443 is always open. 443 as a port is always open because that's how web applications work. But you need to be inspecting that outbound access to, or that outbound flow as well, to make sure that inside that payload, there isn't a whole bunch of data that's being exfiltrated or stolen. And this is something that most people aren't thinking about. So if we go up here, then we can go into policy enforcement. This isn't particularly interesting from the portal perspective, other than to show you a particular feature. We'll go back to our payments application and show you the future of all of this stuff. Allows you to ultimately display the policy. So right now we just have a place in here where you can look and see whether it's a Kipling method policy or a best practice layer 3 or a very minimal policy. And again, this is going to eventually display the full policy, and that's what we're working on. But we can see the score here. And since this is test data, and I probably would disagree that it should be a 5, but again, we're looking at test data, and we're in a demo environment. And then monitor and maintain. This is where it gets really interesting. So you're looking at the traffic, and we haven't had threat traffic into the payments system because we don't allow it, right? But we can look at all of the protect surfaces, and we can start to see what happens if we automate this. And so we're one of the pioneers in using automation and machine learning in the monitoring and maintaining and orchestration of cybersecurity. And it's a very powerful tool. So if you've seen any of my presentations, I talk about the movie The Imitation Game, where the character of Alan Turing says that he has to build a machine to defeat a machine. He's talking about the Enigma machine that created the Nazi codes. And so that's what we're doing here. And because this is proprietary, I can't show you much more in detail, other than we have automated threat response that we use. And this means that we don't really have to have regular analysts in our company. We have manual investigations where about 1 in every 100,000 events have to be looked at. And so it gives us a way to scale zero trust in a unique way. This is the anti-fragility that I was talking about. And so this is all doable. People who say zero trust is hard, no, it's not. If people who say it can't be done, that's not true. We manage about 300 zero trust environments around the world. So just because you think it's hard, or you can't do it, or somebody else has told you that, that's not true. I'm here to give you the real story. It's really easy. You need that 5-step methodology that we're seeing up here at the top. You need that 5-step methodology. You follow that 5-step methodology. You figure out what your protect surfaces are, build your controls according to the protect surface, monitor and maintain it, and improve it over time. And bada bing, bada boom, you're done with it. And so, or at least you're done with building it. You're never done, right? Because it's a journey that will go on forever and ever for as long as you have IT. And hopefully all of us will retire before all of that is gone. But when you retire, you'll retire knowing that your company didn't suffer data breaches, that it stopped attacks from being successful because you adopted a zero trust mindset. Eric, let's chat now.
Okay, well, this is very impressive. And you mentioned this is anonymized data from a real financial institution, and you can see all the examples that you have there that are, typical of, most major financial institutions, most banks. How long did it take to sort of get them set up, to get them implemented?
Yeah, so it's interesting. This customer has been a customer for probably 15 years, so it's one of the most mature ones we have. But for a normal customer, a bank that I did last year, for example, it took to just get started where we defined maybe the first 5 or 6 protect surfaces, and we got them to where we had a good deal of visibility and could show them some progress. That took less than 30 days. That was very, very quick. And that included replacing an old set of firewalls with a new set of next generation firewalls, and some other technical controls that had to be in place, and some endpoint protection. But it was a great example for that particular customer. When we looked at the year-over-year data from the time we started building it to the end of the first year of the contract, we saw 81 million events, security events, not just traffic, but security events.
Wow.
And out of those 81 million, we had 3,000 that had to be investigated. And there was about, because there's so much repeated events, those got aggregated into about 50 different investigations. And out of those 50 investigations, there were 11 times that we had to contact the customer. So we essentially took 81 million events, and we had to tell the customer about it 11 times. And that's the scale you can get when you do zero trust in this 5-step way.
Wow. And how difficult is it to implement when you have sort of legacy type technology like mainframes, or operational technology like ATMs that may not have all the same capabilities that we're used to on, say, a modern Unix or Linux system?
Yeah, let's go back to that slide, that drawing. Give me a second to change. And I think it's best if I illustrate that. Okay, so this is our cardholder data environment, our PCI data. Let's say this is a mainframe, and it's probably a mainframe, right? So we've got a mainframe right here. Could be any kind of server, but we don't really care. And that's probably in a physical environment. And so over here, we're connecting our segmentation gateway to our core switch and then to the rest of our network over here, right? And somewhere down here is the mainframe admin, right? Who's going to run PuTTY and SSH and or run, terminal services or whatever the application is. What we're going to do, one of the key things about all of the things that function as segmentation gateways, they all have an input and an output, right? And so the easiest thing you can do is deploy it in a bridge mode where these two interfaces are tied together inside so that you don't have to disrupt the routing protocol that exists. So what we're trying not to do in something like a mainframe, because it's connected to the main switching infrastructure, is mess with the IT people and make them reroute a bunch of traffic and just change the way the routing protocol works. So because we can do these things in this is typically oftentimes called bridge mode. Bridge mode is a great way to deploy segmentation gateways in traditional physical environments. It's a little bit harder in a cloud. You can kind of do it, but usually there'll be load balancers and other things involved. But in a physical environment where I have to do a protect surface that is a mainframe, well, I just bridge the segmentation gateway into that. And then we can do all kinds of things. I once had to do an X.25 network, right? So X.25, most people on this call have never heard of X.25 as a protocol, but it was a type of network protocol, kind of like Ethernet or IPX or Banyan Vines. We've had a lot of them, Token Ring over the years, right? You remember X.25, right?
Yep.
And so I had a customer that had an X.25 network that they couldn't get rid of. And so what we did is the same thing. That whole X.25 network is the protect surface. We're going to just place a bridged segmentation gateway wherever we can get the Ethernet handoff into it, because it did have to connect to the existing network, just like anything does. And bada bing, bada boom, again, right? We have a zero trust environment protecting an X.25 network. And so these things are all things that we can do. And so we just need to be unlimited in our imagination. Let your imagination run wild and you'll find a way to do it.
Maybe one last question about on the different protect surfaces, if those are correlating with sort of different lines of business or different, departments of functions, front office, back office, commercial versus retail banking, that kind of thing. Are you able to provide sort of different dashboards for different lines of business and different business areas?
Yeah, in our portal, we can define multiple views that we can give different business leaders. So oftentimes there'll be a view for the business leader who's in charge of that particular protect surface, or we can give a different view for an auditor, for example. So you just have unlimited flexibility in how people are allowed to view that, because they're not actually going in and changing anything. So we don't have to worry about them messing up the whole works, right?
Right.
But they can view it in multiple different ways. It's designed to be very flexible. And the more people have visibility into how the thing they're in charge of is working, the more willing they are to say, oh, I see where I can make that better, and then give you the resources, the time, the project manager, the budget, the technology, whatever it is that you need to get that done.
Great. And I really like the way it shows, sort of maps out the 5-step method and tracks the maturity over time. And so it really helps the organization in their zero trust journey.
Absolutely. It's designed to meet the needs of business leaders and technologists both at the same time. Well, Eric, thank you so much for inviting me to do this. It's always fun to work with the Cloud Security Alliance. Great organization, what you guys are doing. It's all available for free. And I encourage people to reach out, ask questions, and let us know what we can do to help you in your zero trust journey. Thanks.
Today. Thank you, John, for presenting, and thank you to our participants for joining us today. If you have further questions or would like to continue the discussion, please feel free to reach out to us at events@cloudsecurityalliance.org. We value your feedback and look forward to hearing from you. Thank you for attending today's webinar and have a wonderful day.